it's a technical problem to get that data off of the microscope and into some place where the machine learning models can access it. The harder part, it turns out, is those plate maps. Now, if the scientist puts them into the digital microscope, of course you can extract those, but we want to eliminate that step. We want to go straight to the machine learning model analysis. And so instead, what we have to do is go straight from the Excel files into a place where the model can access them. The problem here is that typically those plate maps are going to look very different from experiment to experiment, from scientist to scientist, from team to team, because everyone has their own different way of encoding that information. Experiments tend to vary quite widely. So often a format that would work for one team will not work for another team, will not work for another experiment, even by the same team. And so these Excel files tend to be very, they have inconsistent formats for a variety of reasons. And that's fine in the original case, because if the scientist is managing that one plate at a time, one experiment at a time, they can do that manual work. When you, in this new situation with the machine learning model, now it's the data science, the ML team that has to figure out how to manage those plate maps. And so that means that every time an experiment happens, they're doing that. They have to track down the plate maps, figure out how to clean it up. And so this now introduces a lot of extra time, right? It's both time that they're spending, that they could be doing, the machine learning work, the data science work, what they consider their job, they're now spending not just cleaning up those Excel sheets, but actually like tracking them down, right? Because the scientists, they were storing them on their laptop somewhere. They had their own system. Now the data scientist has to figure out which scientists produced the plates, ask them, send them an email, wait for them to reply, get the Excel sheets. Maybe they don't understand what the format is, so they have to ask them questions. And so that can actually take days before they can even start the work of cleaning, and then the cleaning takes even more time. And so what we've seen, what I've seen, is that often this can turn, what should have been maybe a day or two to run the models, it's now 2 to 3 days to track, get the Excel sheets, get the plate maps, and then another day to clean them up, and then another day to run the models. And so now it's a week from when the data gets generated to when you actually have this machine learning generated hit list. Whereas when the bench scientists were doing it themselves, they could do it, in an afternoon. And so now by the time that all happens, it's a week later, the scientists don't care anymore. They've moved on to the next experiment. And so effectively the models, they're not just late, they just are unusable because of that delay. So the question is, how does automation fix this? Because often, especially when you get into experiments where you're doing more and more plates, which is often where the machine learning comes in, there will typically be some kind of automation in the loop. So instead of the scientists preparing the entire plate themselves, now they may prepare some kind of initial plate, and then there will be some automation involved to generate the final plates that go into the digital microscope. And the nice thing here is that automation, just like the data scientist, needs that plate map in order to understand what it's doing, what it's going to do in the lab. But unlike the data scientist, where if they're giving those plate maps to a data scientist, the biologist can give it to them in any form that they want, and the data scientist can clean it up, and make the model work again, maybe after a week, but they can still do it. Whereas with the automation, they don't have that choice. They have to, give it to them, and they have to program the automation. That plate map has to be in a consistent form, or they they can't even run the experiment in the first place. And so now we have we basically have a reason where the biologist, the bench scientist, is motivated to create that kind of consistency that the data scientist needs. Or more often, especially if you're using, say, automata.tech scheduler, you actually have an app that the bench scientist can use to encode all of that information. And the nice thing about something like a scheduler is because it's tracking the plate maps in a consistent form for its own internal uses, that means it also can produce them in its own internal form that can go directly into the machine learning models without manual intervention. Especially if you're using something like a scheduler. So what this means is that now, instead of the data scientist having to spend a week tracking down those plate maps, cleaning them up, before they can run their model. Now it can happen instantly. In fact, you can even extend that automation all the way into training that model and have the data scientists only come in when, for interpretation, for debugging, for things like that. And so, in my opinion, in my experience, automation could make a huge difference in solving these kind of technical problems that are currently invisibly preventing, more adoption of machine learning, AI, data science, and biotech.